Hi everyone, good morning, good evening. I am Abhiram. Today I am here to talk about a recent use case that I have built using the Google ADK. I would like to start this session by thanking all the people at Google for working on this ADK or the Agent Development Kit. I basically named my project as Autonomous Agents Limited, a company run entirely by AI agents. Today everyone is talking about the vibe coding. Vibe coding is nothing but using AI to write the code or using AI as an assistant to write the code. My project is an attempt to take it a step further, so make it a fully autonomous multi-agent AI company. Because what I see in the vibe coding is basically kind of assisting the code, but it's not a kind of setup that is going to plan or create. It's not a kind of setup that is going to do the planning, coding, testing, deploying, or this end-to-end SDLC or the software projects. So the main aim here is to make sure that the company is capable of planning, coding, testing, and deploying the entire software projects without the human intervention. So one of the most advanced features that I like about the ADK Web UI is it's saying, we have a Web UI interface with the ADK, which is multimodal, like you can give an voice prompt to it or a video. So you can say, you can say like, hey Google, just build me a build habit tracker app, and then this agent is going to, this multi-agent system is going to get kicked off, and then you are going to get the app. So that's how it is. That is very easy, at least for prototyping. So the problem statement is why I choose this use case is because real world software development, is very highly dependency prone. There is a lot of knowledge, context, and human dependencies. There is a lot of variations in the styles that people are writing the code, or there are huge changes or fluctuations in the kind of requirement that we get, delays, conflicts. So AI is already adding velocity to our life, and AI agents are going to add velocity to the entire life cycle, and things can get very fast deployed. So why I use AI agents is basically every agent is a natively an LLM under the hood. But the main reason here is the main advantage here with the AI agents is we can allow the division of labor. The main advantage of using the AI agents is AI agents are nothing but LLMs under the hood. But basically, we can set a context or a persona to every LLM or every model, like the division of labor or the kind of autonomous decision making, and we can choose to diversify the LLMs. And basically, an agent is something like you're going to define a goal, and the system of LLMs are going to work with tools and basically give you the output. So yeah, here you can see like for example, a Scrum Master agent can decide which workers to pick from the worker pool, or the CEO agent is can use a Google search tool, right, to check the feasibility, something like that. And then you also have the mindset. The basic and the most important thing is the mindset. You set the mindset to the agent, like you are the CEO of a software company or you are an architect. So that's going to draw the boundaries between these LLMs, and the way they think and the behavior is going to change. So why I use the ADK is basically ADK supports this multi-agent workflows, and then it has several features like this A2A agent to agent protocol, and the most important thing is the Vertex AI memory, uh, which is going to help us in the context management or memory management. And then we also have this Vertex Express mode, so that is like super easy for a rapid prototyping kind of thing. So through just an API, we can do the deployment as well. So coming to the two major features of this ADK is basically the ADK Web UI. So this is something which I like very much because you would ID you there is no need for us to write a Streamlit or Gradio. We can directly go there, and it's kind of setup which I will show you later in this session, that where you can just directly interact and just check all the evaluation, everything you can see there, how many tokens are being consumed, what is the timestamp, what are the events. So it's a kind of transparency tool, and it's multimodal. That's you can give voice prompts, everything. Then it has some advantages like the parallel flows. We can define parallel flows, sequential refinement, loops, everything. So these are basically required for my project, and commands like ADK run, ADK web or ADK deploy is like very easy, right, to use. So that is the mostly the fluidic nature of the ADK is what made me choose this ADK framework. So my project has an innovation. So my project has some kind of the basic workflow of my project is like this. So basically, you have a requirement coming in. So the requirement is coming to the CEO agent. So the CEO is going to do the high-level validation analysis and then tell us, right, that what is you can see the code here. Let's go to agent.py. So you can see here you are the CEO of the software company. So I was supposed to use the Gemini 2.0 Pro. I was supposed to use the model. So this is basically the way we define an agent here. So this is a CEO agent. I was supposed to use the Gemini 2.5 Pro version of it, but I was using the free tier and I was not able to use it much. So that's I was using for PM Architect and then the CEO I was using the 2.5 Pro because of its reasoning abilities. And for the workers I was using the Flash 2.5 Flash because it is very fast. But right now I am just using the 2.0 due to the API free tier limits. So this is basically the way we are going to set the context. You are the CEO, you are going to review the project feasibility, you're going to approve or reject, and then he's going to give an output here. And then basically this is going to be from CEO, it's going to go to the PM, and the PM here is going to make some kind of high level task breaking, and then he's going to give some epics to the scrum master and a high level estimation as well here, and then we have some kind of he's going to decide what all workers are required for this. We have a worker pool already defined. So one of the thing which I couldn't achieve is like I wanted the scrum master or the product manager to create the team of workers dynamically, right? Without creating them already in the pool, I just tried to create them dynamically. Like for example, a requirement comes and the PM decides I need 10 workers for this, then he's going to make 10 agents in the runtime and define agent cards in the runtime, but that didn't happen. So that's why I defined a static pool of workers, like around 2 to 4 workers, and then the product manager is free to choose like how many workers he want. Does he want only a UI worker? Does he want UI plus Python or what all he want? And based on that, he's going to choose. So this is kind of, the ability of an agent, which I wanted to demonstrate here. So that is how then later he's going to give an output key called PM output. Then it's going to the Scrum Master agent and then he's going to do a high level estimation here. And then he's going to, this is a loop between the Scrum Master and PM. So basically these two, the PM is going to send high level requirement, the Scrum Master is going to make some changes. He's going to again send to the PM and then again PM is going to send back with some changes and then this kind of loop is happening here. So to prevent the uncontrolled, I just put the maximum iterations 1 or 2. So yeah, it's like a prompt tweak, whatever you want, we can do. So basically, at the same time, there is another agent called as an architect agent. So without an architect agent, it is something like the Scrum Master is passing the code, the task to the team members, and then the team members are going to, build the codes isolated. They don't know, right, what worker one is doing, what worker two, three, or four. So they don't know each other what they are doing. So it doesn't make a sense to create a unified product. So that's where I added an architect agent here. So what an architect agent is doing here is basically for each is going to create some kind of common guidelines or you can say the architectural guidelines so that the end product is unified product and doesn't look like it's been developed in silos. So that's one of the thing that I am doing. Then the other thing is the most important feature or you can say the innovation in my project is like the architect is agent is already an AI and it is going to directly hit the GitHub Copilot using model context protocol. So this is a really a AI square or the multiplicative effect of the AI usage here, because the architect agent is not doing a static search in the GitHub. So once you get the epics, he's not just doing a keyword matching with the GitHub now. So he's directly hitting the intelligence in the GitHub. That's the GitHub Copilot. He's going to understand basically what are the requirements here, and then he's going to translate them in a way that is used by the team, and then he's going to send them, right? For example, he's going to interpret the internal requirements. First, the AI here at the architect agent is interpreting the internal requirements, and then it is converting them into the intentions, and then it is querying the copilot for the intelligent recommendations from the copilot. So here we are using intelligence and plus intelligence. So intelligence is querying intelligence. This is a kind of innovation and kind of providing a multiplicative effect. And it is also going to give, the architect agent is also going to give some of the GitHub links which are matching to this. And these are being passed on to the Scrum Master agent. So now the Scrum Master has the epics broken down into the stories, and then the architect is going to give him the guidelines, what all the workers have to do, and each epic divided into stories, and for each story the guidelines are being mapped because the architect is giving guidelines on an epic level, and then these guidelines are passed to worker 1 2 3. This is an intelligent routing done by the scrum master here, so he knows what is a UI task. If worker 2 is UI, is going to pass it to him. What is a Python task? Worker 1 is Python, he's going to pass it here. So it is doing an intelligent kind of routing here, not like a if else kind of routing here, or a keyword routing here. We are using pure intelligence here to route the tasks here. So that is one of the major thing. So let us see how we have defined the MCP here. So this is an MCP toolset. We don't need to write any big functionality here. Just you give the connection parameters and then just give the URL of the GitHub. Just get a GitHub token, or you everyone you can see, get it in the GitHub. Just put the in the env.env. Just put the GitHub token here, just set few of these parameters all true, something kind of like this, and then you are going to just run the uh, run the agent, and the architect is going to give the guidelines and all these kind of things. So the architect is also acting like a mentor here by training the workers, right? So what kind of activities, what kind of development they have to do, and what are the guidelines they have to follow, like the structure and all those kind of things, and also what kind of technical excellency that they have to follow. So this kind of intelligence, and we can say some kind of coaching that he's giving them to build an app. So that's where the parallel worker agents are going to work on it. Once the parallel, these are all going to work in parallel. That's one of the native feature of the Google ADK. So this we defined as loop, this we defined as parallel. One more interesting thing I found out is this is a loop, and this loop can run in parallel with the architect. PMSM is in the loop called, I defined it as a refinement loop. See, PMSM and refinement loop, I defined it as a refinement loop. And at the same time, this refinement loop is going to run in parallel with the architect. You can see here, right? So this is where this is something which I found very interesting, right? A loop, and the same loop can be run in parallel. So later I have developed a agent to agent protocol here. The reason why I use this A2A protocol is because in real world usually we deploy to a different server, and MCP cannot, MCP is just a tool here. Uh, so I have used an A2A here, and I have also used one more tool. The CEO agent is using the natively built tool, that is Google search, and then kind of making some kind of research here, and giving some kind of intelligence suggestions, like what I'll use Google search to find competitive features, and we have defined a Google search here. So he's finding the competitive features, and he's also doing the background research while other agents are working. So this is one of the thing. And then for the deployment, A2A protocol is something like, we have once from local to different port. We have two servers here. So I've used the UVCon basically. So the UV is going to be spinned up, and then basically our files are being transferred from here to there. So basically once all the workers work is being collated here, and then it's a dictionary here, and then we are going to get a deployment agent, and we are defining it. You are a deployment agent. Uh, Going to have a tool called this is a Python tool, prepare deployment files, and then that is being passed on to this. So this is one of the usage of the tool here. Then basically we have a deployment orchestrator and a remote deployment proxy here. So basically what I'm doing is I'm kind of running this port Unicorn in 8900. Actually, I tried to do this in the Google, right, from my local to Google, but I had some kind of billing constraints, so that's the reason why I was using this 8900. So basically what happens in this A2A protocol is this deployment orchestrator, they are going to send these so the deployment orchestrator is going to call the deployment remote deployment agent to deploy all the UI workers output. So what is happening? This is a remote deployment proxy here. So the this is being called by an agent card. So we all know agent card is kind of a schema, right, where the agent name, ID, and all those kind of things are defined there. So it is going to identify the proxy agent through the proxy agent, and then it is going here to A, and then yeah, have to have two consoles. So one is this console there where we are going to just keep the server up. So let's wait and see if the server is up and running. Then need to go to the different terminal, and then there are two ways that we can run an agent using web and then using run. So I choose to use so this is the ADK web UI, and then you can go here, build a habit tracker app or whatever app you want. Just press enter. This is going to kick in the multi-agent system. This is basically going to the root agent, CEO agent, PM, SM, architect, copilot, and workers and deployment agent. So you can see things happening here. The CEO are as approved this, saying this is feasible. The reason why this is feasible has provided some additional features. This is the Google search that he has done using the Google search native inbuilt tool. These are the two websites he has researched. And this is the PM agent who has broke down into the epics and the high level estimation. This is basically after you do the ADK web, you're going to give a message here in this ADK web UI interface, and then you're going to say build a habit tracker here, and then you can see all this kind of evaluation kind of events and all are coming up here. So this is the CEO agent. He is doing the feasibility, is giving the reasoning, is giving the additional features, what are was being asked. This is the Google search tool that is working in the backend. It's the habit tracker and all these Google searches he has done, the CEO. Then this is a PM agent who is giving the high level task and the high level estimation here and choosing these three workers, UI worker, Python worker, and data worker from the pools. Then this is the architect agent who is going to do the Google GitHub Copilot, and for every epic is going to give the guidelines and also the GitHub links also, which the developers require, so that he is reducing the overhead on the developers to do the research by themselves, and is also giving the GitHub links to make sure it's a technically excellence is followed. Then this is the Scrum Master agent, so he is going to break down the PM epics into the stories, and then is this an iterative loop. So he is going to recheck with the PM, and then PM is going to approve, and then this happens two or three times based on the setting we have done. and then he's setting up the story points here, and then he's doing the mapping here. So which worker has to do what? So he has mapped this is for the UI, this is for the Python worker, this is for the data worker, and he's doing the intelligent routing here. Then this is the DevOps worker. You can see the DevOps worker is saying, okay, I will generate the development scripts, and he has developed the scripts here. This is the DevOps worker, and then this is the UI worker who has done the UI coding here, and then you can see the UI worker here. Then you can go down. Then this is the Python worker who has developed the Python coding here. They are all giving us the scripts here, and then this is the data worker who has given us his task here. Then we have the QA agent. Basically, ADK is also having a runtime. You can execute the codes as well in the ADK, but the problem is here. I'm not sure if this codes are full because of the token or context limits, whether they are truncated or not. So I just created a QA agent who is going to create a test strategy or test cases, like basically the kind of suggestions, testing, and his feedback, and if there are any quality issues. Since he has not run all this, then he just put this as blank. And see, post the QA agent. These are the test cases that are being generated. This is the deployment orchestrator saying the deployment status is pending. And these are the files, file name app.jsx by UI worker, by Python worker, deploy sh. So now this is transferring to the deployment agent, and this has been transferred. So you can see the metadata here, how the request or the response and all these kind of things happened here. You can see this. These are the graphs. What is the sequential and what is the hackathon flow? All this you can see here, what all happened here in the backend. So then you can go to this. You can see what is the response, request, event. Then you can see the status success. Deployed files are these 4 files have been deployed, and this is our deployment agent. And this is what has happened. This is a deployment orchestrator, sequential agent, and these are all the 4 workers. And you can see this is our root agent, and you can see the entire flow here. These are all the contents. Yeah. Events here, so you can just open any of the events, and you can see what is the metadata under here, what is happening, what is the token count, what is the prompt count. See all this kind of evaluation and observability can be seen here. This is one of the way that we can do it. So this is basically about the use case on a high level, and yeah. So let's go here. So for the deployment, I think I used the agent engine Vertex Express mode. So you have all the material over here. So this is going to show us like how to deploy using Python scripts or using. So Vertex Express mode is very easy. You don't need to define projects and all. You just need to get the API key. Right now there is a 90-day trial that's going on, and then you can directly get the API key and then just follow 2 or 3 lines, and then you can say ADK deploy. If it's you are using the CLI, just say ADK deploy, and then it's going to deploy. You need to maintain a folder structure, or else if it's a Python script, then you can just write a Python script, and then you need to install package here. So yeah, this is what you have to do, the pip install Google Cloud AI platform. And using this AI agent engine, you will also get to access to the Vertex memory, whichever I have told you just now. So for the context management. So some of the upcoming features which I thought was like a multi-turn CEO interaction, where after the entire loop is happening, the CEO is going to ask us back. So are you going to ask the user back? So that these are the activities that have been completed, and these are the future sessions. Do you want us to continue with the development, something like that? And then it's like a real multi-turn conversation that's happening between the user and CEO. and the CEO is going to depend on the Vertex A memory and do the callback, preloading the context from the Vertex A memory, and then he's going to callback based reasoning and answer the user. And if in case if we find something which is something which he cannot negotiate or it's out of his control, then he's going to escalate via emails using the tools. He's going to report it to the owner. So this is the future scope. Some limitations is what I thought I would try to experiment on creating a Slack-like feature where the workers can post their doubts and the other workers can answer, but I don't see that happening because the worker has to pause and resume. That kind of functionality is not there. So the deployment agent creation was not supported. Dynamic agent creation. I thought that the Scrum Master dynamically or the PM dynamically creates the workers, but in runtime, the agents and the agent cards are not being created in the ADK. Some I also see that only we have to stick to Gemini for this ADK, and we can't use Grok and all. So A2A demo is I was not able to use the cloud, so I used the 8900 billing constraints. So I tried the Git and push and pull, but that did not work. So basically, this is the LLM choice. I used 2.5 because for CEO, PM, and architect, it needed deep reasoning and a long context and analysis. So, and even code review also. But for all the execution, I used the 2.5 light flash. Sorry, the 2.5 flash because high volume upload need to be done it very fast and the memory consolidation as well. Yeah, thank you. Bye. Yeah, so this is the deploy.py. So this is using the agent, AI agent to deploy. So we need to follow this, like we need to give the API key that we get from the uh, Express, Vertex Express. Just put the API key here, and then we are going to create this app, and then this is what, and it's going to say that the deployment is finished, and it's going to give us the resource number. We don't need to enter any project ID.